Ever wondered how communication systems or round-robin tournaments are analyzed? Well, the answer to this question lies in the magical world of mathematics, specifically through the use of communication and dominance matrices. These two concepts play a crucial role in a multitude of real-life scenarios. Let's start with a quick overview of what matrices are. In essence, a matrix is a rectangular array of numbers, symbols, or expressions, arranged in rows and columns. Imagine a grid filled with numbers. That's essentially what a matrix looks like. Now, you might be wondering, how does this grid of numbers help analyze communication systems or rank players in round-robin tournaments? Well, that's where communication and dominance matrices come into play. In the context of communication systems, a communication matrix helps us understand the flow of information within a network. It provides a visual representation of who is communicating with whom and how frequently. On the other hand, a dominance matrix is used in round-robin tournaments to rank players. It's a tool that helps us understand who has the upper hand in a competition, based on their past performances. Each player's victories and defeats are recorded in the matrix, allowing us to see at a glance who is dominating the tournament. These matrices aren't just fascinating mathematical concepts, they're incredibly useful tools. They help us make sense of complex systems and competitions, breaking them down into understandable, digestible information. And the best part? They're not just applicable to communication systems and round-robin tournaments. These matrices have a wide range of applications, from computer science to economics, and even in the study of social networks. So, as you can see, communication and dominance matrices hold significant importance in our everyday lives, often in ways we might not even realize. They're more than just numbers on a grid. They're a way for us to understand and interpret the world around us. Let's dive deeper into what matrices are and how they work. So, what exactly is a matrix? Well, it's really quite simple. A matrix is an arrangement of numbers, symbols, or expressions, neatly organized into rows and columns. Think of it as a grid, where each cell holds a unique piece of information. Each row runs horizontally, and each column runs vertically. The size of a matrix is determined by the number of rows and columns it has. A matrix with 3 rows and 2 columns, for instance, is known as a 3x2 matrix. Now there are several types of matrices, each with its own unique properties. A square matrix, for instance, has the same number of rows as columns. An identity matrix, a specific type of square matrix, has ones on its diagonal from the top left to the bottom right, and zeros everywhere else. It's like the number 1 in the world of matrices. Multiply any matrix by it, and you get the same matrix back. Then there's a diagonal matrix, another type of square matrix, which has numbers on its diagonal and zeros elsewhere. And let's not forget the zero matrix filled with, you guessed it, zeros. But why are matrices important? They're crucial in solving systems of equations, performing complex calculations, and representing data in fields such as computer graphics, physics, and economics. Reading a matrix is straightforward. You simply start at the top left cell and read across the row, then move down to the next row and repeat. Easy, right? Now, when it comes to interpreting a matrix, it's all about context. In a social network, for instance, a matrix could represent the relationships between people. Each cell could indicate whether a person is friends with another, or how often they communicate. With these basics in mind, we can now explore communication and dominance matrices. So, let's dive into the fascinating world of matrices and see how they help us make sense of complex systems and scenarios. Ready to understand how matrices help us analyze communication systems? Let's dive right in. Communication matrices are a type of mathematical matrix that represent communication links within a system. They're particularly useful in fields like network analysis, where they can help us understand how different nodes or parts of a system communicate with one another. A communication matrix is typically a square matrix, meaning it has the same number of rows as columns. Each entry in the matrix represents a communication link between two parts of the system. If there's a direct link, we put a 1 in the corresponding spot, and if there's no direct link, we put a 0. Let's consider a simple example. Imagine we have a system with 4 parts, A, B, C, and D. A communicates with B and C, B communicates with C, and C communicates with D. We would start by drawing a 4x4 matrix with rows and columns each representing one of the parts. We then fill in the matrix with ones and zeros based on the communication links. For instance, as A communicates with B and C, we would put ones in the first row, second and third columns. The beauty of the communication matrix is that it gives us a clear snapshot of the communication within the system. It's like a map showing us who talks to whom, but it doesn't stop there. It also allows us to analyze the system structure and predict its behavior. For example, by looking at the communication matrix, we can quickly identify isolated parts of the system or parts that act as bridges between other parts. We can also track the flow of information or influence through the system, helping us understand how changes in one part might affect others. So how do we interpret the results? Each row or column of the matrix represents a part of the system, and the ones and zeros tell us about its communication links. The more ones a part has, the more connected it is. Now that we've mastered communication matrices, let's move on to dominance matrices. Ever wondered how to rank players in a round-robin tournament accurately? Well, that's where the concept of a dominance matrix comes into play. Imagine a round-robin tournament where each player competes against every other player. The result of each matchup is either a win or a loss. The dominance matrix is a mathematical tool that provides an organized way to represent these wins and losses. So, how do we calculate a dominance matrix? Let's break it down. First, we create a square grid of cells for the matrix, where the number of cells on each side is equal to the number of players in the tournament. Each cell in the matrix represents a matchup between 2 players. If player A wins against player B, we put a 1 in the cell corresponding to that matchup. If player B wins, we put a 0. In case of a tie, we can put a half. And it's as simple as that. By filling out the matrix with these values, we can visualize the outcome of all the matchups in the tournament. But what's the point of all this, you may ask? Well, the beauty of a dominance matrix lies in its ability to rank the players. By summing up the values in each row, we get a score for each player. The player with the highest score is the dominant player of the tournament. And there you have it. A clear, objective way to rank players in a round-robin tournament. No more arguments about who's the best. The dominance matrix tells it like it is. But that's not all. Dominance matrices can also be used in a variety of other contexts, from analyzing social networks to studying ecosystems. So the next time you're faced with a complex set of interactions that need to be sorted out, remember the dominance matrix. It might just be the tool you need to make sense of it all. With these 2 types of matrices under our belt, let's recap what we've learned. We've covered a lot of ground today, haven't we? It's like we've been on a journey through the exciting world of matrices, specifically focusing on communication and dominance matrices. So, let's take a moment to reflect on what we've learned. First, we delved into the understanding of matrices, the rectangular arrays of numbers that are such powerful tools in mathematics. We explored how they are defined, how they can be calculated, and the different ways they can be used. Remember, the size of a matrix is determined by the number of rows and columns it has, and each entry in the matrix represents a specific value. Then, we ventured into the realm of communication matrices, special types of matrices that represent communication systems. These systems could be anything from social networks to transportation systems. We learned how to calculate a communication matrix and how it helps in analyzing the flow of information within a system. It's fascinating how mathematics can help us understand and optimize these systems, isn't it? Next on our journey was the concept of dominance matrices. We discovered how these matrices are used to rank players in round-robin tournaments, where every player competes against every other player. The dominance matrix helps us see who has the upper hand in these tournaments, providing a clear ranking of the players. Throughout our journey, we emphasize the importance of these matrices in real-life scenarios. They're not just abstract mathematical concepts, They have practical applications that influence our everyday lives. From optimizing communication networks to